Hello, this tutorial is about making conda-forge packages by me. This is the logo of conda-forge. I'm not affiliated with them, but I put the logo here mainly because the slide was very empty. Yeah, this tutorial is gonna basically go over the steps and the theory of how to do it, but not really all the details because each package will be very different, so I can't tell you exactly how your package will need to be made, but at least you'll get some idea from this if you're just starting out. Just a disclaimer, I am not an expert. I have made a couple of conda-forge packages, but definitely not an insane number. But I just thought that since I couldn't find another good YouTube tutorial on this, I thought I'd make this because some people, like myself, prefer watching a YouTube video over diving straight into documentation. Still, to make your package, probably you will have to read some documentation in the end. But at least here, I hope to give you some idea. So to start, you can skip over this if you already know what conda and pip are, but just for the people who might not know, conda and pip are both package managers with which you can install usually Python packages. And for users, oftentimes they don't really know what the difference is and why one would prefer one over the other. The commands are pretty similar, so why even bother to make conda packages if we have pip, for example. Pip is kind of the default package manager for Python. So it's used to install Python packages from Pypi, pypi.org. There are lots of packages on Pypi. I think there's, now, 280,000 almost. So quite a lot of packages. And usually the packages are uploaded in kind of a source code format. So what you actually upload is a tarball of just the Python source code because you don't need to compile Python generally, right? And the, let's say, installation instructions, which is just telling pip how to actually install the package, which means putting the files in the right place, is in some kind of, you write as a developer a setup.py file, and then everything is handled for you, basically. That's how you create a pip package. You create a setup.py file with the right instructions. And this works great if you're working with pure Python packages, but once you start having other languages in your project, then things can become a lot more complicated. For example, if you rely on certain C functions or maybe C++ Fortran, then that code has to be compiled on the system of the user, and you have to write those kind of instructions also in the setup.py file. It can get quite complicated and things can go wrong if the user system doesn't compile things correctly. So generally, pip and then combining it with other languages is really not ideal. And this is where conda has sort of an advantage. So with conda, you're not downloading from Pypi, but you're instead downloading from Anaconda Cloud. And it's a completely different repository here. So basically with conda, the main difference is you're not downloading usually source code, but you're already downloading pre-installed platform-dependent binaries. So if you have C or some code in your package that needs to be compiled, then this is already done by the people who uploaded to conda, to Anaconda Cloud. And when you install with conda, you're just downloading the binary. You don't have to compile it on your system. And that's quite convenient from a user's perspective, makes things a little bit easier for the user. So generally, Conda can manage any type of software in any type of language. It's not only for Python, and it's great when you have multiple languages, basically in your project. Much easier to distribute than on Pypi, I would say. And so one of the ways in which Conda got popular is in its combination of sort of the scientific Python stack with NumPy, SciPy, Matplotlib, because all these libraries depend heavily on C. And so with Conda, that was much easier to manage. Conda is created by Anaconda, which is a company, and it's distributed through the Anaconda or Miniconda distribution that you can get from their website. And Conda doesn't rely on the Python interpreter, so it can basically behave like a platform independent package manager, as you would have sort of a system package manager on a Linux distribution or so. Another advantage of, or another feature, I guess, of Conda is it can be used to create virtual environments. So you can create nice little boxes on your system where you have, let's say, different versions of different software installed, completely isolated from each other. That's also a very nice feature. So Conda is convenient when you have multiple languages, multiple programming languages, especially languages that need to be compiled in your project. Very convenient to distribute your software this way. But one of the downsides of this infrastructure of Anaconda Cloud is that the packages are distributed over multiple channels. So basically, usually when you install something via Conda, you would type conda install package or whatever. But what you're basically doing then, unless you've messed with the settings, is you're only looking inside one channel, namely the Anaconda channel. And that's the official channel by the Anaconda company, basically. If you want to download from any of these other channels, then you would have to add an extra argument, conda install C, and then if we want to install from the title of the presentation, conda-forge, it would be something like that. So to specify the channel. Now, having all these packages of different versions and built for different platforms, so you can see here lots of platforms, some of them less, fewer. We have different versions available. It can get pretty messy on like which channel do you want to install something from. And so this is kind of the problem that conda-forge is trying to solve. So they are trying to be sort of the default community package channel, because on the official channel, this is completely managed by the Anaconda company. You cannot add packages to this channel. You cannot contribute to them. You cannot update them. This is totally out of your hands. You can only update to channels separate from Anaconda. But you don't want all your software to be distributed over so many different channels. You just want one community channel, basically. And that is what conda-forge aims to be. And so if we go in there, you can see that they have around 12,000 or almost 13,000 packages built into conda-forge. And actually conda-forge is extremely popular. As you can see that actually the NumPy version of conda-forge is more popular than, let's say, the so-called official NumPy version, because the conda-forge also tries to stay more on top of the game in terms of having the most recent package versions. No, we're more recent on conda-forge, which is nice. So before we go into how to create a conda-forge package, how to contribute to conda-forge, we will just we will first look at actually how conda packages are built, because this is how conda-forge is also working in the background. So understanding sort of the structure and idea behind building a conda package is sort of a prerequisite to the conda-forge process. So I'll just run through the example that you can find in the conda-build documentation here. And yeah, if you don't care about this, you can obviously always skip ahead. But well, first what we want to do is we want to have, so what we're going to do now is build a package locally on my system. And this is not how conda-forge works, but you'll see the structure of the package. So anyway, so the first step is, of course, to install conda-build. And you'll see that this is actually installed already on my system, but we'll let it run anyway. Okay, it appears I have to update my conda version, but you can see all the requested packages already installed. And then basically I have access to the conda-build command. So what we need to do first, here I'm in this example directory, and I think this should be empty. Yes. And we're going to try and build a package. Well, the same package from the documentation is called click. So it's already available on Pypi, which will save us a little bit of time, because actually there's a conda-build utility with which you can sort of automatically already create a template from a package that's available on Pypi. So you don't have to start from scratch, because that can be a little bit more work. So what we're going to do is, I'm always typing in the wrong window. Conda, I think it's skeleton, and then Pypi click. And that'll run for a while. And basically what it's going to do, you can see it's finding this repository, I guess. And it's going to look through the setup.py file and basically find sort of the necessary dependencies. And it's going to create a bunch of files in some temporary cache folder from which a build can then be generated. And this can actually take a while. So it appears to be done now. And if we look now in this folder, we can see that a new directory called click has been generated. And inside, you will find a meta.yaml file. And this is the key part to creating the conda package. So, and I just wanted to go over this because this you'll also see come back in the conda-forge part. This is the essential part basically. So you see that the metadata that we require in this file is some information on the package, like name and version, the place where the source code can be downloaded from, in this case, of course, Pypi. All of that stuff is filled out automatically for us in this case. How to actually install the source code, let's say, or the package, which kind of dependencies that we have, and then metadata like where the project is hosted, what kind of license you have, a summary, and then probably you have to edit this, like you will be the maintainer basically of this package. And that's more or less it. Now, if you didn't start from a skeleton, then you would have to basically write this out manually, this type of structure. Now note that we have Jinja templating enabled in this file. So basically we can set some variable, like click is basically the name, and then we can reuse that variable in other places throughout the meta file basically. So we'll exit out of that, And so in this case, we don't need to make any edits, but when we have a more complicated package to build, then most likely we will have to make a bunch of edits in this meta.yaml file. But in this case, because it's the example from the conda-build website, we can just do conda-build and then click. And this is also, again, gonna take a while. Okay, so now you see that it's done. And what will have happened is that in some location on your system, it's rather hidden away, but well, it tells you where it is. A tar archive will have been created. And this you could then use to upload to Anaconda Cloud on your own channel, basically. Or you could, so this is telling you how to do it, or you could also install this now for your local machine. I think with conda install and then click local or something like that. But for this, you should check the conda-build documentation, basically. It's somewhere in there. I'll link to it in the description. So that's basically it. Now, you should note, and I can't stress this enough, that this seemed quite simple. We had to just wait for a little bit, but in fact, you will have to most likely do quite a bit of editing in here, especially in this requirements section. That can be quite a bit of work to get it to work properly. So it must be noted that the kind of dependencies listed here, okay, now there's basically none, but if you have a lot of packages here, they need to be the names that can be found on Anaconda Cloud on the channels available to you. And in the case when you're building conda-forge packages, those will have to be on the conda-forge channel. So for example, an issue that could be in this case, so if the package on pip depends on PyQt, which is for making graphical user interfaces, then the automatically detected package from the conda skeleton command, whatever package name that's entered here, will be incorrect because the name is actually different. So you can see that in Anaconda Cloud, you would have to install PyQt with this name. But if you were to install from Pypi with pip, you would have to use PyQt5. There is no PyQt. So the names of the same packages can be different on the two systems. So that's definitely something to be aware of. So take care that whatever you're putting in this requirements is actually the name that can be found on the Anaconda Cloud channels, basically. It needs to be able to be found here, and the channel needs to be accessible basically to you. So if you have set in your configuration file that only you want to download from Anaconda and conda-forge, then it won't look for the name in any of these other channels, basically. So something to be aware of. So now this was a pure Python package, and we only have a meta.yaml file. But if you are building a more complex, so there's only a meta.yaml file, right? But if you're building a more complex package, you will most likely need some kind of command line instructions to instruct conda-build what to do. It won't know what to do, for example, in certain cases with C++ or C or Fortran code. So to do that, something helpful is that you can use build scripts. And so let me see if I can find that. Yes. So you need a meta.yaml file. That's required for all of them. This is the recipe. But then for the more complex packages, non-Python packages, for example, On Linux and Mac, you will need a build.sh script, which will be run basically after some preliminary steps here. So at number 7, it will run the build script, whatever you have put in there. And on Windows, if you need to build on Windows, you will need a bld.bat file. And then optionally, you can have a couple of other files, but these 3 are really key. So if you're building more complex packages, you need to really take care of this build.sh file or build.bat file. So that's very important, and that will also help you understand the next part. So now let's finally go over to making conda-forge packages. And what you want to do as a first step is go over to the GitHub repository conda-forge staged recipes. So you're ready to start making your own recipe and contribute it to conda-forge. So you want to go over here, and the first thing you want to do is fork this recipe. Not this recipe, this repository. And I've already done this, so I have my fork over here. That's me on GitHub. And what you want to do here is to create a new package, you will want to create a new branch that has the name of your package, for example. So in my case, we'll look at some of these, one of these later. But if you want to, so you can see I already did some dummy thing. But let's say we want to add a new package, add package Y or Z, right? And then in this branch, we would create edits to the recipe. And how do we create edits? We would go into the recipes/example, and we would basically edit this meta.yaml file. And you can see it's very similar to what we saw before, only there's a couple of comments between to tell you what to do, basically. Now it's a very, very simplified one, as it was the other one. So for more complicated recipes, you will probably best look at some of the other examples, and we'll go over that later. But so, I'm not going to start a new recipe from scratch because it's quite a bit of work, but we will just go into one of the packages that I've made before. So that's on the branch exit wave, and this was to build a package called exit wave reconstruction. This is a package I found on GitHub, and it's C++. If you want to build it on your system, you need to do all kinds of gymnastics. It's generally not really fun to build this kind of stuff, and I ran into lots of issues when trying to compile it locally. So to save other users from this, I thought, hey, why not create a conda-forge package out of this? So it's a nice example because it's a little bit more complicated than just a pure Python package. So if we go in here and on this branch, look in the recipes, you can see there's a example folder, but we've created 2 new folders in there. And this one, C image, I needed to create that one because it was a dependency of exit wave reconstruction, but it wasn't yet available on conda-forge. So that's something that can happen if you want to build something and the dependencies are not conda-forge. You will first have to create a recipe for the dependencies to also get them into conda-forge. So sometimes that can be a little bit some work. But so if we look in the C image part, you can see that the meta.yaml file looks more or less recognizable. Very simple meta.yaml file because actually the C image thing is just a header file. And so all that needs to happen is basically it needs to be downloaded from the GitHub repository. And then in these build scripts, all that happens is that this file is moved to the right place to the right folder, basically, right? So that's C image. If we look at the exit wave reconstruction, what we have in here, the meta.yaml file, is a lot more complicated. So here in the build, we have to define some kind of compiler. We need CMake. We need a bunch of other stuff, and quite a lot of dependencies here. And all of these are available on conda-forge. So you just have to look for them in Anaconda Cloud, basically. But to create this is kind of a lot of kind of iteration. And you'll see that later. But the build script in this case is basically calling CMake, right? With setting the CMake flags and all that, make, install, and then move a couple of binaries to the right place where they can then be called from the command line. And that would then effectively have installed the package. So that's basically exit wave. And so if you were to create your own package, you've created your branch, you've created your folder and your meta.yaml and your build files, you've uploaded them to your fork. Usually you would do this locally, right? You clone the repository, you make a branch, and then you push it back up. It makes much more sense than you using this GUI interface thing. But so once you're happy with your recipe, then the next step is to create a pull request. So you would do pull request, and in this case I've already done that, so I'm not going to go through with this, right? But you would create a pull request to conda-forge stage recipes, the master branch. All right. And so we'll go in here. So this was the pull request that I created for exit wave reconstruction. You can see it's from exit wave into conda-forge master. It was already merged. And in there you will find a handy checklist to check, did you really do these things correctly? So they're helping you a little bit. And luckily they have a bunch of bots active on these on GitHub, basically. So there's a linter that will check whether there's mistakes in your recipe. So for example, here it told me there's a space missing or something, which is a mistake. So then you create a new commit and you fix that. Then it tells you, okay, it's fine. And then basically what you need to do is just wait. So whenever you trigger a pull request, it will automatically launch their continuous integration services on Azure. So I can't show that on this pull request, but we can go in and look at another one. So if we go to conda-forge stage recipes, well, not issues, pull requests. So these are pull requests by other people, right? And you can see this one is not successful and this one is successful. So maybe we can go in here. So this is another guy trying to get this whatever package into conda-forge. And you can see here, this is what you would see in your pull request. So it's launching some basically it's trying to build it on the Azure servers. And if it doesn't work, then you will see that. To see the details, you would go in and check basically what's going on. So let's view more details on Azure. And so bash exited with code 1. Let's go in and check. And then you can see, where things went wrong, basically. So let's see. What is the problem here? Some test failed. Okay. But so basically you can see kind of the the build happening, and when errors pop up, you can sometimes know what to do, and then according to the errors or whatever feedback you get from this, you update your recipe basically. And so in this way, it's kind of a very iterative process where you're adding and subtracting certain requirements, for example, to see whether it will build on the server or not. And because I don't know very much at all about C++, C, or Fortran compilation, I luckily had my colleague Jan over here helping me out with the recipe. So he was suggesting a couple of things to add to the meta.yaml file. But so basically you can see a bunch of commits, which is constantly changing the recipe. And then, yeah, after a while, so quite a lot of stuff. But then when it's successfully built, basically, you can ping the mods and say, come check it out. You know, once there's the little green check mark, when that's there, you know, when it's ready, checks have passed, you ping the mods and you say, hey, you know, my recipe is ready. Could you please merge it into the master branch? And they will look at your recipe and say, you know, they don't like certain things, please change this. So then you make some changes, and after a while, if they're happy with it, then yeah, they'll give some more comments. After a while, they will say, we approve this, and they merge it into conda-forge master. And then when that happens, basically the first step is done, or it's more or less done, right? What will happen then is after a while, your package will appear on Conda Cloud under conda-forge. So you can see in this case, you can conda install with, on the conda-forge channel, this exit wave reconstruction, which was my package. And in this case, I have only made the recipe for Linux so far. I highly recommend, if you want to try and make a package, try and build it first for Linux. So they will accept it if you are building only for one platform. But if your tests keep failing for the other platforms, they won't, the mods won't accept your recipe. So try and build for one platform first. Usually Linux is easiest to get it working, because with Mac and with Windows, there's all kinds of additional weird caveats. Try building Linux first. And when that works, then you can go on to the next step if necessary. But anyway, so once your package is on Anaconda Cloud, what will also happen is automatically a feedstock repository will have been created. So in conda-forge, and then the name of your package, feedstock. So hello, change of scenes, because someone started vacuuming in my house and you couldn't really, well, it was very distracting in the video. So anyway, we're back on our exit wave reconstruction feedstock. And this is the repository where you want to make changes if something needs to be updated or changed in the recipe, which will then update the Anaconda Cloud package. So this will have been created once you have a successful pull request, and you will see that you or whoever you mentioned in the pull request will be the maintainer. You will have full access to this repository. However, you should never directly edit or commit to any branch on this repository, not master, not create another branch. You shouldn't do any of that. What you should instead do, so let's say that now in my recipe, I've only got this built for Linux, right? The exit wave reconstruction is built for Linux. So if I want to add a recipe for Windows or for Mac, I would go and fork this repository. And then when I fork it, I would make a branch there, say add Windows build or whatever, and I would make my edits there and make a pull request to this repository, to the master branch. Now the difference between the previous pull request and this one is that you are the maintainer basically who has to accept and merge the pull request. The reason you don't want to push directly to this repository is that every time you do, the CI services get activated and whatever is produced gets uploaded automatically to the Anaconda cloud. So it's very wasteful if every experiment, every build gets automatically uploaded. So you want to do your experimentation in the fork, and then only once it works, you want to trigger a new build in the main repository. So the pull request, all of that stuff is the same. You will see you will be able to see the same Azure pipelines. All of that is exactly the same. The main difference is that it will be you who has to check that everything works. Now, usually, like if you don't want to really change anything, what's really helpful is that there are some handy bots to help you out. So basically, yeah, these bots, so for example, this one will automatically detect when new versions of the software become available. So basically when someone pushes a new version tag to their GitHub, it gets registered and the bot will trigger a pull request and say, hey, this software gets a new version. The bot will automatically update the necessary files. So here you can see it changed the version number, it changed the SHA-SUM, and that's basically it. So all of that happens more or less automatically, and you don't have to, keep up with the versions yourself. And then all you have to do as maintainer of the feedstock is merge these pull requests. So can I quickly show that? Come on. Yeah. So, and that's basically maintenance, right? So to summarize, super small. All right. So to create a conda package in general is you want to install conda-build for your system, create a meta.yaml file, and possibly if it's a more complex project, build.sh and bld.bat. You want to have a conda-build, and you want to do conda-build package name to create the thing on your system, and then you want to upload it. This is not the way to do it because then you have it uploaded to some weird channel, right? If we want to do it the correct way, creating a conda-forge package, it's a little bit more complicated, but definitely more rewarding. So you want to fork the conda-forge repository, conda-forge feedstock. You want to create a new branch on your fork. You want to edit the YAML file and basically create the recipe, and then enter a pull request to the master branch. You want to iterate and use the continuous integration services on Azure to see if the build works. And then once the mods approve your successful build, your package will appear on the Anaconda cloud in the conda-forge channel. To maintain your package, you want to keep an eye on the new feedstock repository that gets automatically created. You want to accept updating pull requests by the bots. I haven't had any issue with them, but if the build fails, of course, you will have to do some manual intervention. And if you want to make changes yourself, like you want to add support for another operating system, you want to fork the repo and make pull requests. And so definitely, I haven't gone over much of the details on how to actually, you know, what to actually put in the meta.yaml file or in the build scripts. And for that, you will definitely have to read some documentation, right? So I would highly recommend at least read, like if you're building a more complex package, go into this conda-forge documentation and read some of this stuff under knowledge base. This can be very helpful for you. I don't know much about this at all, but this can help you construct your meta.yaml file. And also in general, you can read the conda-build documentation. And otherwise, there's always the help. You might be able to get help from the conda-forge Gitter channel. So this is a very busy channel, but yeah, you might find some people who are able to help you out with building a more complex package, for example. And that's about it from me. So I hope you found it somewhat useful, and I hope this will get you started on creating conda-forge packages. Thanks.